August 8th. You know, it might just be the absolute greatest date in the entire history of math. Welcome to this explainer. Let's jump right in and figure out why. Because on this one specific calendar date, spanning entirely different centuries and continents, several brilliant minds were born who literally built the world we live in today. It's kind of wild how a single day can pack so much historical punch, right? So we're going to meet these mathematical detectives one by one and trace our modern technology all the way back to their birthdays. Let's start off with a mystery. Have you ever actually stopped to think about how the tiny little chips inside your smartphone pull off millions of calculations, juggle heavy apps, and push brilliant graphics, all at the exact same time without just completely freezing up? Well, the answer brings us to our first mathematician, Paul Dirac, born August 8th, 1902. Dirac was a guy who believed that instead of relying on physical concepts, we should really just trust the math. And by doing exactly that, he pioneered the mathematics of quantum mechanics. He literally discovered the hidden rules that govern tiny particles, like electrons. And those complex equations, they are the absolute bedrock of all the modern electronics we rely on. So it boils down to this. Every single electronic device you use is secretly powered by quantum math. The entire digital world we're swiping and tapping through every day, built entirely on his mathematical schemes. All right, still on August 8th, but we're going to jump forward 8 years to 1910 to solve another pretty incredible mystery. Have you ever looked up at a plane and wondered how a massive, incredibly heavy metal tube flies faster than the speed of sound without just breaking apart? Like, how on earth do we engineer something with that much power to actually stay in the air? That brings us to our second incredible mind, Johanna Weber, born August 8th, 1910. What's absolutely fascinating here is how she applied her mathematical skills. Using some seriously complex aerodynamics, she designed these slender, arrow-shaped wings of the Supersonic Concorde. Working with her team, she drew up revolutionary wing shapes that totally defied standard aircraft design, which paved the way for the highly efficient Airbus planes we're all still flying in today. Her equations quite literally shaped our world. The big takeaway here is that the very shape of modern sky travel was drawn by mathematical equations. It's just mind-blowing to think we travel the globe safely today because of math that she calculated, mostly by hand. Okay, same date, 11 years later, now we meet someone whose ideas built the invisible networks surrounding us right now. Think about this for a second. How do computer networks, and the internet itself, instantly find the most efficient pathways for your data? Why does a website load in a blink? And how does your data know the exact route to take through millions and millions of servers? Well, the answer brings us to number 3, Edwin Spanier, born August 8, 1921. Spanier was an absolute master of algebraic topology. Now, that's really just a fancy, formal way of saying the math of abstract shapes and spaces. He created theories that quickly became the go-to standard tools in theoretical computer science. His work on formal languages is actually what helps map out the wildly complex, dynamic, digital systems our computers rely on every single day. Which brings us to a pretty mind-bending realization. The invisible web of the internet is built on the pure math of shapes. Those unseen pathways connecting us right now, they're actually guided by Spanier's mathematics. So one date, so many stories, right? Let's take one last jump, 10 more years, to our final mind for today. Since we can't easily just look through a telescope and see them, how do we know for sure that mysterious, invisible black holes actually exist out there in deep space? How did humanity ever prove that massive black holes are out there just swallowing up stars? The answer brings us to number 4, Nobel Prize winner Roger Penrose, born August 8, 1931. Penrose used pure topological mathematics to prove that when a giant star collapses, it must create a singularity. By doing this, he mathematically confirmed that black holes are, without a doubt, absolutely real. He showed that under certain conditions, our classical rules of general relativity just break down. Basically, he looked for the math when physical observation was literally impossible. And that leads to this really beautiful thought. The darkest, most massive secrets of the universe were unlocked with nothing more than a pen, some paper, and math. He proved we could uncover the cosmos's hidden mysteries right here on Earth. So every single person we've met in this explainer today, spanning totally different centuries, different countries, they all essentially asked the exact same question. They looked out at the wild, unpredictable, and sometimes totally overwhelming chaos of the physical world and asked, what is the pattern hiding inside this chaos? And because they relentlessly looked for that pattern, we hold the future in our hands today. Because they dared to ask that question, we have smartphones, supersonic flight, the internet, and the mathematical keys to unlocking our universe. So I'll leave you with this. What hidden patterns are you going to look for today?